Okay, I think we'll get started so we stay on time. So welcome to our session. This is going to be a bit of a deep dive in getting more true to the core APM product and the Java application APM product that we support and that most of our customers use. Really excited to have all of you guys here. And I think this will hopefully be extremely insightful. A lot of the stuff that we're going to cover will be some newer roadmap product strategic material that's not released in the product right now, but we wanted to have an opportunity to show you guys some of the exciting things that we've been working on. And so, with that said, we're going to be talking about next-gen configuration, and then we'll have a second part of the talk that'll be catered towards more Java deep dive diagnostics, some of the features we're building to give you more data inside, more visibility inside the JVM and all your transactions that work in the JVM. So my name is Akrit Prasad. I'm a product manager on the APM team, and I'm here with Vinay Srini, who's an engineering director on the APM team. So as I mentioned, we will be talking a little bit about some things that aren't in the product, but up and coming, exciting features. So legal has always asked us to keep a couple seconds on this slide, our safe harbor slide. So I'll just browse through this quickly. So the question was if these slides will be available after the conference. I do believe that
we are recording, so I.
Yeah. Great. Yeah. Thank you. So with that, let's get started with let's go over the agenda real quick for what we're going to cover over the next hour with you all. So we'll first start with what we're doing for at-scale configuration. And we'll kind of explain the reason why, and most of this will probably be pretty familiar to most of the folks that are on a daily basis working with software and performance and monitoring. And then we'll transition to talking about, in addition to building a very scalable, flexible configuration model, how can we give you more live, effective rule configurations? And so we'll talk a bit about what we're doing for live traffic introspection to give you effective rules. We'll couple this efforts with demos so that you can get a real life picture with our prototype applications and get a good feel for what this will potentially look like. And then we'll shift gears and talk about Java performance diagnostics. So features were built there. So some of you, or hopefully most everyone here was in the keynote yesterday. One of the areas that was mentioned was threat contention. And that's a really powerful feature that we've been working on, and I wanted to share that as well. And then some of the work we're doing when you look at all transaction performance, what are we surfacing in the garbage collector to give you more heuristics and more data for understanding how you can optimize your JVM. So, when we get started, I will say I have a minor sore throat, so if I start sounding like Darth Vader towards the end of this talk, please don't throw a lightsaber at me. So, APM vision. Our APM vision has always been to give you end-to-end application performance visibility. So, that comes with understanding transactions from the start, mapping your entire environment effectively, tagging and following transactions through different services that you have in your system so that you get not only service level visibility for different endpoints that you're monitoring, but also a user transaction performance. And then, of course, coupling that with end user and database and infrastructure and other product areas that we have. So, what this allows us to do is because we're able to map transactions and follow the path, we can very quickly identify areas where there's performance issues that are happening. And so, this capability is instrumental for us to be able to monitor your applications and give you real-time performance data so that you can continue to monitor and improve your application health and your users are never impacted by major catastrophic events in your application. So, it's crucial though that as the configuration, as your applications tend to evolve and become more rapid and scale, our configuration model also needs to evolve with that to enable you further with being able to configure rules and detection and transaction visibility effectively. One of the most powerful features of our product actually is all the configuration capabilities for folks that have gone into the instrumentation section and seen all the rules that we have and all the different conditions you can apply for different kinds of detection, whether it's transactions, backends, errors, data collection, info points. So it's very powerful, but we want to make it more scalable so that you can apply it to different services. So let's look at why that's important. So there's a trend, and of course this is probably familiar with most folks here. The software architectures, the infrastructures that kind of run all these services have been evolving. Since 1990, there used to be a lot of spaghetti code. That was kind of like the first wave, decoupled services working together. It's very interesting how this actually relates to Italian food, and that's why I wanted to throw that up there as well. But you have this spaghetti code, essentially. And then firms realized that as we continue to scale and attract more users and build more growth, we need to come up with a more structured model, and that's where this layered monolithic kind of a model came about, where you have your more coupled, where services are a lot more coupled, and you have your web servers that are connected with your app servers, and which app servers connected with your database, and so you have a more strategic layer architecture for scaling your business. But what's starting to happen now is that over this current decade is a lot of these applications are starting to, the scale at which you have to monitor your application performance and the scale at which the users that you have is growing massively. And so there's another model that's being adopted widely, which is the microservice model. And so you're essentially taking these monolithic services at the app layer, the web layer, database, and breaking them out into smaller services so that you have more agility, rapid deployment, and have more decoupling so that features can be released without too much contention. So with that said, from our end, what that means is we've been monitoring applications since the company was founded back in 2008. We used to back then monitor tens of applications within a controller. These are different JVM, .NET, Node, different applications. We started with JVM back then, and as we ourselves continued to attract more customers and started to see more dynamic environments to monitor, we started to see a growth in the applications that we're monitoring even for our controller. And we started to go from tens to hundreds to now there are certain areas where we're seeing thousands of applications reporting into a controller. And so what this means is our ability to scale our application configuration power and enable you further with AppDynamics means we have to evolve our configuration model so that you're able to essentially continue to have more flexibility with AppDynamics. So we'll go into a specific use case of how this helps, but some of the model today is very hierarchical based, and so you can see from this example here that as your services grow and you start deploying more monitoring capability with AppDynamics, essentially you're going to have more and more services reporting into a controller, and it could be that a lot of these services are actually part of a similar subset of activities or capabilities. And so you may sometimes want to group certain services to enable certain detection rules, whether it's common transaction detection or certain errors that you're looking to detect and build further visibility with. So today, there's not a clever way to do these grouping, right? You can apply rules at an app level, but as soon as you want to apply certain rules to maybe 10 out of 20 tiers, you're going to have to go to each of those tiers and apply it one by one. So we're working on a solution that's more flexible that allows you to essentially group services and scale your configuration. So I'll hand it over to Vinay next, and he'll kind of walk you through a specific use case, and then go into a demo about this.
Right. So if you've used AppDynamics right now, how do you configure your business transactions, right? So one way to do it is stack on all your rules that you have to the application. Now, be it backend rules or error configuration rules or transaction monitoring rules, you tack them on to your application, and all your tiers implicitly get those rules, right? So that's like a hierarchical model. Now, that's very simple, but none of our applications are that simple, right? So what if I need a new rule for only my tier? Right? How do I achieve that today? So now what do? I take my application, I copy it to my tier. That's how it works today at AppDynamics. You make a copy of all your rules to your tier, and then I tack on my new special rule onto that tier. Now, seems simple enough, but what if you have a lot more tiers like this, right? This operation itself, when you want to change your original rule, let's say I want to change my check rule on the top there, it requires really 3 operations, right? One, I modify the original rule. I have to remember that I had actually copied it to my other tier, and then I modify that rule as well. So there are too many human interventions here, right? It's not very scalable, and it's very error prone. So if you forget to change the other rule, it might not be the end of the world, but you don't get the business transactions that you need. So it's reliable error prone, obviously, so we want to change it. So that's why we are introducing what we call the scope. So Adam talked about it a little bit at the keynote yesterday. We are introducing the concept of scopes and rules all through the product slowly, and it kind of has started with license management. We are introducing that in transaction detection configuration, and we'll kind of roll this out into multiple different areas going forward. So the idea is that you have a scope that has your applications, that has just your application. So that means all your tiers currently belong to your application, and that kind of becomes an implicit scope. So when you upgrade, when this gets out, the GA, when you upgrade, we will have a default scope for you, and we'll tag all your tiers to that default scope. And that's how you'll be upgraded to. Now, I'll create a special scope. If that shows up. There, okay. So I'll create a special scope for my tier, and then I'll tack on the right rules to the right scopes. Right? So we've introduced the scope as a buffer in between your tiers and your actual rules. So now I don't have to remember anything. There's no duplication of rules. So the check rule and the prod rule are just one copies, and my special rule is just one copy, and I distribute it to all the tiers that I need through the scopes that I'll define. Right? So there's nothing to remember and nothing, no more errors. So with that, I'll just jump in here so that we have some context as to what we are talking about, and I'll show you what we are looking at. So that's my application. So we'll jump into configuration and instrumentation. So the transaction detection screen is being reworked. So this is not the screen that you might recognize, but this might be the screen that you will recognize. So where you have your tiers, and all the rules that belong to those tiers. So right now, all these tiers have exactly the same rules, right? So if you go to rules, this will list you all the rules that you have in your system. And then the scopes, I have a default scope here. So this says all tiers in the application. So that's the default scope that we'll ship with. You could change that. I've also created all my front-end tiers, which is in this scope. I also have another scope that says this is just the backend tier. So you can create as many scopes as you want, associate, mix and match all your tiers with these scopes, and have the rules attached to them. So that's the basic idea, so that you don't duplicate any of your rules.
So
right?
This stuff is extremely powerful, as Vinay just demonstrated. I mean, you have the capability of creating any permutation of any of the tiers and services that are monitored with AppDynamics and apply any kind of rules you want with our extremely deep rule capability today. But oftentimes, you may, so say you have a model where you have a lot of flexibility and you can apply all these, any kind of rule you want to any collection of entities. But just because you've been able to kind of group them in such a way doesn't mean that the rules may be as effective as you would like them to be. So with that said, we'll transition next to what we're looking to do to give you more effective rule-based configuration. And so, for anyone that's a power user of AppDynamics, which I'm sure a lot of folks here are, this is extremely powerful. Ability to have a much more flexible grouping of entities and your tiers into what we're calling a scope, and then being able to apply an effective rule. So, oftentimes, just because you have flexible configuration doesn't mean you have an effective rule that's applied to it. So what we're doing to make the rules a lot more effective is to solve or improve on the following conditions. For example, today, you can do a lot of matching and splitting with our capability. We want to be able to give you live instrumentation on top of that so that you can see that if you want to build certain rules, in real time you can connect to an agent and look at how that data looks like, and if these rules are actually going to be extremely effective in your BT discovery. In addition to that, sometimes they can be misconfigured rules. You can essentially just type the wrong Pojo name and then or a wrong class name, and then you may not have a transaction detected that you'd be expecting to see. So we want to be able to surface live data, take your rule, apply it live to an agent, and see how this data surfaces in the context of transactions that would be discovered in your business transaction list. And coupling with that, so what can happen often is also that you have tons of different services that are being monitored with AppDynamics out of the box. It could be that some of the services are essentially these auto business transactions that we create. If you want to go ahead and, for example, create a specific Pojo transaction to be monitored, it could be that it's being masked by something that's already being monitored, right? So we want to be able to surface that level of visibility to you as well. so that you instantly can determine that, okay, if I go ahead and create this rule that I'm really interested in monitoring a business transaction with, is it going to impact any other transactions that I have in my system? And that'll help you better understand how is your code laid out and where can we provide high value and more visibility.
So there are a couple of ways that you do it today. One is you have a QA environment or a staging environment where you try your rules out, and your rules really work well, and you kind of move it up to production. But as we all know, QE or staging is not really a substitute for production, and production load is really different. And you might not really get the exact same business transactions as you need on production a lot of times. So it's important that this feature helps you with your production load, right? So you can try these rules out in production in real time, and then apply those rules the right way. And because most often than not, you create a rule, and it either creates too broad of a business transaction that is practically useless, or too narrow, and then you get a lot more business transactions than you can really consume.
So the real power of this, we're going to be demoing to you relatively soon as well, so you'll show 2 different examples of this. But I wanted to get to one last thing, one other area of improvement we're working on, which is unInstrumented code detection. So in your application, we detect a lot of things out of the box, but continuously new frameworks are being involved, newer technologies are being built. You may start to use some newer framework that we may not have out-of-the-box capability for yet, or it could be that you're using a lot of custom code, some custom processes that you've written, and you know that these are running in your service, but AppDynamics out-of-the-box may not be detecting it. What we built, or we're working on building, is essentially this feature that allows you to look deeper into the JVM and be able to find all sorts of uninstrumented transactions that may not have an instrumented entry point, and give you the flexibility to instrument it and build an instrumented entry point. And so,
right. So think of this as your IDE, right? When you're developing, you're trying to debug something, and you're wondering why is there a null pointer exception here? You put a breakpoint, and then the IDE kind of stops the thread, lets you introspect what the params are, what the invoked object is, what stuff is in it. So here, what we are trying to do is not obviously stop the thread, because we don't want to stop your thread in production, but we pause the thread, collect all the data that you need, and then let the thread go and put the data up here so that you can introspect what's happening with that method. So as Akrit said, we detect a lot of stuff out of the box, and it could still be that you are using a custom timer-based background transactions that we don't automatically detect or unable to find. But we have instrumented all the exits, though, right? In this example, we have an HTTP exit that's instrumented. We know that this is not part of a transaction, and we kind of highlight that here. So, go ahead.
Will this also going to help us on the standalone Java, which doesn't come through the web traffic?
So the question is, will it help with standalone Java? I think that's a good point. Yes. So.
Predominantly, some of the scenarios, it just picks up the data from database and processes it.
Right, I think that's a very good example. Standalone Java processes that don't have a standard entry point like servlets or JMS or Spring or struts, this will really help there. And you can actually introspect that live instead of guessing. We have a similar feature, like a debugging capability with a node property, if people know what it is. It was called find entry points. So you could set that node property, and the agent would start logging all of that in the agent logs. This is more of a, I would say, fancy version of that, where you can actually do it in the UI. So it gets built up here.
I think. Oh, sorry. You can use the clicker.
So another thing that we're actually doing, as Akrit mentioned, is when you're building Pojo entry points. So let's say you have identified a class and a method that you want to instrument. This is the one that I've talked about, where we can introspect the method that's coming in, show you what the invoked object is, what stuff is in there. Is it a servlet? What parameters are in it? What can you get out of the method? We could show it to you live on the controller, as long as you're connected to a node that has some traffic on it. Right? If there's no traffic, we cannot introspect, obviously, but if there is traffic, we can send you samples of all the data here. And one thing to note here is that while we build all of this, we are trying to make sure that there's no overhead in your production. So there are limits on some of these stuff, where the agent makes sure that it doesn't send too many of these. If you have 1 million transactions a minute, we don't want to capture 1 million samples of these. So we capture 100 and stop until the next minute comes by. Because in most of these scenarios, you will need a few samples to determine what your business transaction should be. So this kind of talks about the thing, what Akrit touched upon. You might be creating a new transaction that is already part of another transaction. So what does that mean? So you're trying to create a Pojo rule, which is part of a timer that's running. So your transaction is not really tracked in that sense. But it's also called as part of another servlet request that's being called. So this will also tell you that of the 169 times in this example, it's masked around 27 times, something like that. So you get an idea that, yeah, I still need this Pojo rule that I create to create the transaction, but it might also be masked by these other transactions that are going through the system, which will be OK, because you still want to monitor what's not monitored. So let's say you do not have any exits. You still want to monitor something. It could be the standalone app example. It could be anything else. If you have a hint as to what the class name is, then you can search for it in our class method browser. Right? As long as you're connected to a node that has the class loaded in it, we can surface that class. You can look for all the methods in the class. We'll also tell you if it's instrumented or not. So that you kind of get an idea whether if it's already instrumented, why is it not working, or is it the wrong instrumentation, and so on. And then you could start from here and add a Pojo rule and go forward from here. Right? So that way, you could do that. Now, taking it back to servlets, we talked about Pojo a lot, where you can instrument that. Servlets are already instrumented. We should already be detecting transactions for you. But it might be too broad. Right? You might have, in an example that Akrit will run through with you, you might have a URL that says 2 segments, but then you really want a little bit fine-grained detail on what that transaction is. And that fine-grained detail might give you 5 more transactions, but that's really what you need to monitor your performance. So this tool will help you identify all the HTTP traffic that is coming into the system. So think of this tool as an inverse of what you would see in Chrome developer tools. So if you want to monitor what's going on in your browser, you open up the developer tools and look at all the network traffic. It'll show you all the URLs that are being hit to the server. You can click on each of the URL. It'll show you the parameters and headers. This is the flip side of that from the server view. So this will capture all URLs that are hitting the server, along with its parameters and headers and cookies and anything else that you can think of for the URL, and it'll surface it here. So you can get a grand view of what's happening in your system live right now. And then you can make up your rules based on that.
So I think with that, we'll dive into showing you a quick demo of both of these, of 2 situations where you can use uninstrumented code to build a Pojo entry point with live traffic, and then how you can split high-value business transactions using the live servlet introspection feature we built. And this is, I just want to stress, it's really interesting to see this, because what you're about to see is all live data. We're sending information to the agent as we demo, and it's going to stream data back to you. And this is, in some extent, never before seen APM capability that allows you to build real-time high-value business transactions, where previously, you would essentially be kind of trying out a configuration that you expect to work and then wait until the BTs are registered with it. This way, in real time, you'll get that visibility.
Right. So let me start with the Pojo instrumentation. So what I'll first do is, let me back up a little bit. I went too fast. So you go configuration instrumentation. You have transaction detection here. You have your rules. Now, you want to create a new rule. So what we do is we start a live preview mode, which will start a discovery session. So I'll start it on my web tier. So now this will start streaming me all the business transactions, right? As we can see on, once the agent connects, we should start streaming some data here.
So again, this is all happening live. This is, as we start this session, the controller is sending information to the agent, the specific node agent that we connected to, and we limit the connection to keep sure that the performance isn't too heavy. We want to essentially limit also the user sessions that can enable certain live connections with agents to keep impact in production as minimal as possible. But these are features we're building designed to work in production. And instantly, you'll start surfacing you data that the agent is seeing in real time.
So as you can see, this is getting updated live, and the demo guards are with me today. So, let's keep it that way. So what I want to do is try and see if I can get the uninstrumented traffic going. Now, this is a simple servlet app, so everything's instrumented. What I'll go do is try something here. I'm opening up the Java auto discovery rule, and I'm disabling all discovery of servlets, right? So now that's sent to the agent, right? And now it won't discover any new transactions because the auto servlet discovery is off, right? So let's see if, and voila, you have all the uninstrumented traffic showing up right here. So this is how it shows up, and it will also tell you all the number of times it's being called. So it gathers all the information based on the stack traces that it collects. So let's open the statement.execute query, right? So this is the statement.execute query that's happening here. And we can find a good method to introspect, right? I'll add a Pojo rule to it. Let me call it something. So, right now I started live preview for this rule. So what we were looking at before was a live preview for an entire set of rules, right? And this is the live preview for this rule alone. Now, it's not necessary that you actually launch this in context of that other discovery session that we talked about. This can be launched standalone, as Akrit will show you later on. So this is streaming live data now. So that's the transaction that I just created. Since I named it test, it just named it test, right? So that's the name of the transaction that shows up. So I might want to split this transaction in a more smarter way. So I'll go to tools, look at method invocations. So now the agent knows that it has to start sending me samples whenever that method is invoked. So there are a couple of samples. I have very low load on the system so that I don't bring the machine down. But so here's all the data that's coming in, right? So now I can start splitting by any of these fields there. So what the agent does is it looks at the object, looks at the fields, gets the value of the field, and then tries to convert it to a string if it's a primitive type. If it's not a primitive type, it walks down and creates an object tree out of this, right? So let me make it very simple here. I'll try, there's a URI in param0. So just go to root configuration, split.
Another thing that's interesting while Vinay is typing that out is you can see that the match class method, it's already pre-filled. So if you refer back to when you were looking at the uninstrumented stack trace, from there when you build a Pojo rule, we'll pre-fill all that for you so that you can instantly start seeing transactions that you want to see for that specific entry point.
So entered param0 URI. Let me just apply. Okay, let's go back to preview business transactions. And let's wait for the new data to stream because I just changed the rule. And now I get the new transactions that will be discovered. So this is all happening live, and these are not real business transactions. We call them transient business transactions because you're just looking at them here. So these are not masked by anything right now because I had automatically disabled the automatic rule. So these will be the transactions that will be created, right? To just complete the story, I'll assign this to a default scope, and save. Now, in a couple of minutes, those transactions should start showing up here. Because until now, they were just transient business transactions. Now that I've saved all the transactions, set them all up, those transactions will show up here in a couple of minutes. And we may want to come back here later just to see if they really showed up or not. Demo guards are with me, so they will show up soon.
So, so that's extremely powerful. Now you're
Right.
able to look at uninstrumented code, and now you're able to build instrumented entry points, and not only instrumented BT entry points, but also be able to split them based on certain method parameters that are high value to you, and be able to instrument the performance of that onwards with all the extra AppDynamic capabilities such as alerting, baselining, and health rules and metric analysis.
So you have a question? So the question is, what exit points do we instrument today? We instrument a lot of exit points, like all the common ones that you can think of. HTTP, RMI, database, those are the common ones, but web services, all kinds of web services like Spring and WebLogic, WebSphere. Sorry, go ahead. Yes, message queues, yes. Yeah, and anything that goes outside the system is considered an exit point in AppDynamics lingo. So Yeah, so all of those will bring up the uninstrumented traffic detection, yes. Right.
Okay.
I'll repeat the question.
Yeah. So did that answer your question? Okay, I think for sake of time, because I know people have a lot of other sessions upcoming, let's just do questions at the end. We'll make sure that we keep a buffer time for that. That way we can keep flowing through the content and make sure you guys get a chance to see everything we want to talk about. So the next thing we want to quickly show as well is, how can you use the live introspection feature that we built for splitting servlet transactions to get more granular high-value transactions. So let's look at this sample application here. I have a product store application. And automatically we will show you we'll split transactions, servlet transactions by the first two URI segments. But I know for a fact that in this application, I'm using certain parameters to look at specific indoor products, such as furniture, electronics, and different product categories. So what if I wanted to monitor those transactions, and I wanted to actually make sure that in real time I can see if there's load detected if users are using these transactions. Let's see how we can use live instrumentation to do that. So we would go into configuration, as Vinay showed earlier, instrumentation. We'd go ahead and build a rule. In this case, we'd want to build a servlet rule. We'd call it something. In this case, let's just call it product group. And then make sure that we apply it to a certain scope where all the different agents and entities are collected. And then when we go into rule configuration, we can actually go ahead and initiate a live preview. So let's actually start a live session on the node. And here you can also see that we'll show you if agents are up and running or not. So you won't be starting a session on an agent that's not up and running because there won't be any data reported. And so let's browse in the tools real quick, and then I'll explain when we get to preview business transactions how this data gets more granular. So the first thing that we added capability for is to let you see all HTTP requests coming in. So this allows you to see in real time all HTTP traffic coming into your JVM. And you can introspect further. You can look at header, cookie, or any parameter data that's captured. In some cases, there may only be parameter data or certain header data. So this is extremely valuable to look at real-time transaction data. But in my specific use case, I know that I'm capturing certain parameter values to land my users on certain pages that I know are high value to me and for my application. And so I want to make sure that I create BTs out of these certain parameter conditions. And so what I can do here is, in real time, we're breaking out for you all the different name value pairs of different parameters as well as associated load. So you can see pretty quickly here that I've got a category parameter for my indoor products, my books, my living room products, my utility and equipment. So maybe I want to use this parameter and split my transactions based on this. You can instantly come here, name transaction using that parameter, it'll autofill, and then we can go into preview. So in preview, what it'll do is it'll actually take these conditions that are on the right and feed them to the agent. And in real time, agent will, for any transaction detected, feed it right back. And so what you're seeing here is we're starting to see all the different individual BTs generated from the different product groups based on parameter splitting. So again, parameter splitting capability has been in our product before, but the ability to see all that data in real time is extremely exciting and gives you a lot more power to build the right kind of transactions that you want to monitor with AppDynamics. So in this case, I did mention earlier that transactions can be masked. I didn't go ahead and unmask the original transactions. So we'll show you if you're splitting certain transactions, they may be already masked by existing auto transactions, and you can go ahead and exclude those original auto transactions. So you can go ahead and then save this rule, and it'll persist, and then you'll see it in your rules list here. And then when you get back to the business transaction list, you should start to see those transactions detected here. It takes some time for the business transaction registration, and within a couple minutes, you'll start to see transactions split by that parameter value, and now you're able to monitor in more detail that high-value BT by certain specific indoor product pages that your application services. So we'll come back to the screens and see the final result later. Now we'll kind of switch gears and talk about something a little different. We'll kind of transition into what we're building to surface more Java, JVM, deep diagnostics, and performance data. So, how many people here have run into contention analysis issues in their application servers where you have a major contention problem, you just can't seem to figure out what's causing it, why is my application not being able to scale? That's a huge pain point for a lot of folks. Essentially, your applications, as they become more modularized and more microservices driven, you tend to have more shared resources. And so that can lead to a lot of contention. And we want to be able to surface that so that you have another level of depth to understanding how your transactions are performing and why, if they're latent, what's the kind of the reasoning behind it. In addition to that, we'll also talk quickly about some work we're doing to improve the performance of all transactions in the JVM. Sometimes there are issues that impact all transactions, such as garbage collection performance. And we want to be able to surface more data to you there so that we can build more intelligence and be able to eventually give more performance advising based on the information that we see. So let's first start with what we're doing with contention. So as I mentioned before, thread contention, just a quick 101 slide. When you have threads that are essentially queued, waiting to get a lock on a resource, that essentially is what thread contention is about. So we do have capability in the product for deadlocks and other things, but thread contention we've not had before, and so this is new. And so this instantly, if you have any threads that are waiting are blocked in any state, we want to be able to surface that. It's extremely critical, contention visibility for scaling your application services. As you can see that, there are a lot of charts that illustrate this with more data. But as you begin to scale your applications with adding more and more threads in the system, you'll run into resource contention. You're going to have services that are going to be sharing things, and it's almost impossible to find enterprise-grade services today that don't have shared resources, right? So, it's getting more and more common in microservice architecture. It's critical for DevOps monitoring, and most importantly, it's very difficult to RCA sometimes without having the necessary visibility with an APM. So what are we building to give you that level of depth with contention analysis? So again, this was lightly touched on in the keynote, and we'll go a bit deeper in this session. So the first thing that we do is, we have a lot of capability, visibility we surface in a snapshot. That's essentially where we sample the entire transaction, collect the entire call graph, slow methods, all sorts of heuristics, and surface that to you so you can have a much crisp view of the performance issues.
Akra, do you want to just show it here? It's probably better live.
So while I'm talking through this, Vinay will actually pull up the sample application that will actually have contention on it. So the first thing we do is we will surface to you in the transaction snapshot. Vinay, if you go to the overview page. So what you can see here is, we'll as a potential issues, we'll show you if there's any contention in this transaction. So you find that there's a transaction that is either slow or maybe it's normal with our baselining, but you want it to be even faster. You want to figure out why is it not operating it faster than it should be. If there's any contention, we'll surface that on any of the segments. It could be that there's multiple segments and they all could have contention, and we'll show you that in the potential issues. From there, you can see the dynamic type of the object that's contending, and you can drill down into that specific segment. Now, when you drill down into that segment, what we'll show you in the call graph is we added this new column called thread state, which is essentially going to tell you the state of the thread while it's executing across the stack. And if there's any point in the execution where that thread is essentially contending or blocked, we'll surface that time. So you can see pretty quickly here that this thread, this segment took about 9 seconds, but about 5 seconds of that time it was actually blocked. And if there's any wait time there, we'd also surface that as well. And then, so that's great. So now you've been able to identify, there's some contention in my application. Where in the application stack is it happening? Next thing you want to know is, why is this contention happening? Who's blocking me? What we built on top of that is to show you, the array of objects or threads that are essentially that you're contending on resources with. So you can see here that on your thread that's executing for this segment data that we captured, you're essentially blocked on another thread trying to acquire lock on an object, and we'll surface the dynamic type of the object. In this case, it's just object, and we'll tell you the associated block time with that. And then we'll also show you where in your code and line number are you blocked, so that you can then instantly get visibility into where in my code am I having contention problems. And on top of that, if there's an array of other threads that are also wanting to get a hold on this resource, we'll show you that array and the associated block time with that. Now, it could also be that you may have in the execution other areas where you're having contention, and we'll surface that entire list here as well. And I have an example of that pretty soon in the slides. So what's neat is that instantly you've been able to see now you understand there's contention in my application, where is it happening, and now you understand why is it happening, what are the threads I'm blocking on. And if there's contention anywhere else in the stack, we'd actually surface that as an aggregate view up here as well, which will tell you the total block time. In this case, there's only contention in one service. So with that, let's...
So it's also important to note that we used to have the total time and the block time and wait time in our previous releases of our software, but it required you to enable the ThreadMX beans thread contention monitoring enabled. Otherwise, we wouldn't be able to get the data. So there's some argument that that will kind of slow down your system. So it's not common that people enable ThreadMX beans feature. But for this change here will not require you to make that flag enabled. So we just get that data for you here automatically. So then your snapshots are much more richer with all the synchronization blocks that are happening in your system.
So we'll switch back to the slide deck real quick, and then so we kind of walked you through a lot of this in the demo, so I'll go over these slides relatively quickly. But as you can see, another thing I wanted to add is in the thread state, we'll even surface to you CPU time if you have dev mode enabled. So capturing CPU time per method requires some overhead. We're very conscientious whenever we build features that cause any overhead to your application that we put it behind the feature flags. And so we built this into the dev mode capability. So if you enable dev level monitoring per method, you'll be able to see if there's any certain methods that are eating up too much CPU time as well. Again, you can see this is another example where you can see which thread you're a part of in the overview section. And you can see that at a certain line number 136, you blocked on thread main and thread 16 on contending on this object and the associated time. And then again, at another line number, you're again blocked on the same thread. And so you can then have much more context to understanding why am I blocked in this thread, and then look into the code and try to understand what's happening. So likewise, we actually built this functionality. Oops, sorry, going backwards. Into the service endpoint as well. A lot of folks are pretty specific monitoring service endpoint capability. So we built that in service endpoint so that if you're concerned about performance of your service endpoint and your services, contention visibility is 24/7 there as well. In addition to that, sometimes the thread can be just in waiting state. So we actually are now going to capture every single wait state in the JVM. There's 6 primary wait states. Here I've shown 3. Whether it's sleeping, it's object wait, thread join. We'll capture all that time and show you in your call graph so that instantly if the BT is slow due to any waiting activity, you can go and modify that in your code pretty quickly. So that's pretty interesting, pretty cool stuff that we're working towards, giving you more data and visibility into the JVM on a per transaction level for contention analysis. But there's also oftentimes there's systemic issues that can happen in an application. You can have network congestion. We're working on building a network monitoring feature to couple with the JVM so that you can get visibility into network performance issues. But network issues can be BT agnostic. They might actually impact all transactions. You could also have hardware scaling issues. You could have virtual memory paging, other issues like that impact all transactions. We focus on APM, so at the app level, oftentimes a big issue in the JVM is garbage collection. If you're not optimizing the garbage collector, then essentially you can have all transactions that are incurred by latency. So what are we doing to further our JVM visibility into garbage collection? So real high level, garbage collection, why is it important? I think most folks here are fairly extremely technical and would obviously know this, but the big benefit is memory management. It helps you avoid memory leaks. You can have memory leaks in the JVM with garbage collection, but it helps you avoid a lot of memory leaks with this capability. And it's extensively tunable. In the JVM, there's tons of different commands for tuning your throughput collectors, your CMS, G1, all the different collectors you have. But it comes with its own drawbacks. You need to tune it to actually get that optimal performance. You can't always depend on ergonomics, depending on how your application is built and how it's working. And that requires a lot of monitoring as well. And that's the first step to give you that visibility to monitor these applications, monitor the JVM garbage collector in more detail, so that then you can get a lot more heuristics and better understand why is my JVM not as optimal as it could be. So these are some of the things we show you today. We can show you young generational heap sizes, old gen heap, perm gen, meta space for JDK8, and code cache space as well. But what we're working to show you further is, how is the JVM actually performing? Not the garbage collection memory pools in the JVM and the spaces consumed there, but what is the performance of the garbage collector itself in the JVM? And that comes with showing you things such as allocation rate, promotion rate, free rate, live data, and I'll get into these in just a second. But this graph is kind of interesting. It's taken from an Oracle site. It just illustrates that if you don't optimize your JVM, then as the time spent for garbage collection, especially these long stop the world pauses that stop the entire application and do garbage collection, they can significantly impact the throughput of your application. So it's extremely critical to understand how the JVM is behaving and where are the drawbacks, what can you optimize and be able to see further insight. So with that, what is allocation rate? Allocation rate essentially is the rate at which your JVM is allocating objects onto the heap. Often it's the young heap. If they're too large objects, they may go directly to the old heap. I won't go too much into the JVM architecture, but essentially there's young heap, old heap, and then there's this perm heap for like class loaders, loader data. But the big issue is if your allocation rate is very high and your JVM is not tuned to the proper footprint, you can essentially run into more frequent young garbage collection. These are usually fast, but they're all stop the world pauses. So they will incrementally impact all transactions running in your JVM. Promotion rate, on the other hand, is essentially promoting objects from your young heap into the old heap. And so promotion rate is another important factor to monitor, because if your promotion rate is very high, you can run into more frequent full garbage collections because your old heap will fill up faster, and then the full garbage collection cycle is actually a lot longer. What also can happen is you can run into premature promotion. So you may be promoting objects prematurely that are actually short-lived objects that shouldn't be getting promoted. And then again, you're going to incur a penalty with the garbage collector doing your memory management for you on the old heap instead of the young heap. On top of that, it's important as you're tuning your JVM to monitor the free memory. How quickly are you freeing this memory? If there's a memory leak, then obviously the freed memory will continue to, the rate at which you free memory will continue to drop, and so that'll help you give heuristics pretty quickly to understand, if there's issues with the JVM tuning that can be refined further. In addition to that, I think live data is also very important. What live data means is essentially what is all the live objects I need to keep my JVM up and running for the course of the application runtime. So you can imagine that you may have all sorts of singletons, factory builders, different kinds of classes and methods that are needed to keep your application robust and running with the features you have and your application. But what can happen is that these, as you start building more and more capability and more features, and if you don't scale or tune your JVM properly, you essentially may increase the footprint of the live data. When the live data footprint increases, then you can run into all sorts of issues, such as more frequent full garbage collections, longer full garbage collections. You can run into higher out-of-memory probability of out-of-memory errors, which can run into crashing your JVM. And you can also have more heap fragmentation. For folks that use CMS or G1 collectors, there's a concurrent full GC that happens, and that actually, because it doesn't do compaction every time it does a full garbage collection, you can run into a much more fragmented heap. And so it's important to monitor your live data size so that you're actively allocating enough buffer and enough capacity for in your JVM, such that your live data, the objects that are needed to keep your application running, don't essentially consume almost all the old heap space and could potentially crash your application from other activities and capabilities that it has. So I think with that said, we'll conclude. Vinay, if you want
one more thing that I wanted to add on the GC side is that it's not easy to get some of this data, because you will have to either listen to JVM events in JDK 1.7 and up, or you have to put out GC logs that you'll have to look at it yourself. And GC logs is not written in a way that you can actually chart it on a graph. So somebody needs some expertise to look at it and chart it over time. The data that we actually surface is both sides. If you're putting out GC logs, we can parse it. If you're JDK 1.7 and above, we can listen to events and actually generate metrics out of them. Where it will really help is that these metrics are saved in our database, and release to release, you can start looking at what's my live data release to release. Is it increased? Is it decreased? If you're making a real effort to reduce your live data, did it really work or not? How's my garbage collection doing over time, and so on. So I think the historical data is more important here, because if you just look at the GC logs at one point in time, you will have to maintain all that data yourself in some kind of Excel sheet, release to release. Yeah.
So again, this is getting way deeper into the JVM for giving you more visibility and coverage inside the JVM with our agent. And what this also allows you to, another point to add is that when you capture all these metrics, you get the rest of the capabilities of AppDynamics, such as baselining, alerting, building health rules on these certain metrics, so that you can monitor them 24/7. So then instantly if your JVM is misbehaving, or there's you push new code out and basically the performance of the JVM degrades significantly, you'll get alerts with the alerting capability of AppDynamics. So just to quickly summarize, we spent time talking about configuration at scale, what we're doing to build a more flexible model to enable you with AppDynamics as you start growing your services and monitoring more and more services. In addition to that, we wanted to make sure that the rules that you built are also extremely effective and efficient, and that came in with the live introspection feature that we've been working on. For performance diagnostics and low latency for your transaction, visibility to provide low latency for your transactions, we talked about contention analysis. I'm happy to share that actually this feature went out in 4.2.5. You need a 4.2.5 agent and controller to be able to use the feature because it requires work on both sides to be able to build the capability. But that feature is out as part of our mid-year marketing release. And then tuning the garbage collector is another area that we're working extensively on to give you more heuristics and insights. And we eventually want to be able to, on top of that, give you more intelligence to say, maybe you should tune your garbage collection this way because this is the patterns and this is the machine learning we've understood looking at your JVM performance over the past several months. So with that, I wanted to thank you guys a lot for being part of this talk. I hope you found it insightful. A lot of this stuff is, in the mid to late stage development, so we can't comment on exactly when it'll be released, but we're working really hard to get this capability to you as soon as possible and empower you further with AppDynamics. And happy to take any questions you guys have at this time. Thank you.
Go ahead.
You talked about garbage collection and the containers there. In Java 8, G1 is default garbage collection, and container structure is very different than what it used to be when it comes to sizes and purposes. How is that going to affect what you're reporting on, and to what extent?
You want to take that?
Okay, yeah, so I think for G1, right, so we test our garbage collection visibility and capability with G1, CMS, and throughput, the most common collectors now. And even inside G1, we'll show you all the different memory pools.
Late stage.
And we have tested this capability to show you allocation rate and promotion rate on the JVM when you're tuning with the G1 collector as well. So you will see all the same data and any additional memory pool data that the G1 collector uses. That's critical for monitoring. Another question? Vinay, there's some other questions. If we can pass the mic.
Will a snapshot be taken if the thread has gone to an infinite loop?
Well, so there's another feature that we have for stall detection. So you have, you know how business transactions are ranked: normal, very slow, slow, and stall. All of them have different thresholds. Out of the box, I think the slow threshold is 3 times the standard deviation, and very slow is 6 times the standard deviation. Stall is about 300 times the standard deviation. So if the agent detects that the transaction is 300 times the standard deviation, what it does, it takes a thread dump at the moment of when it detects it, sends it to the controller, so you kind of get a heads up on whether a transaction is stalled or not. No, it's all out of the box, yes. And then if the transaction completes, that is, if there's no deadlock, it eventually completes, we send another snapshot up that will merge with the original snapshot that we sent with the total time of the transaction. And then you'll be able to see the call graph and the thread dump, where it was stuck and all of that together. Can you pass it on after that? After you.
Are you guys doing similar work for the .NET garbage collector, or is it just totally focused on JVMs?
I know there is some efforts going on to provide more visibility inside the .NET GCS. Well, I can't comment too much on it because I don't work primarily on that product. But if you have a chance to check out the demo booths on the 4th floor, there's a .NET demo booth, and the product experts and engineering experts are there to help answer those questions.
With some of the business transaction splitting capabilities, are you going to start increasing the actual amount of business transactions handled by the agents and the controllers?
So today, there is no real hard limit on what the agent can actually monitor for you. It's more about memory overhead that it creates and the number of metrics that the agent generates. So those are soft limits. They can be changed just by very simple configuration, which is, you could find it on our docs site. It's really, as I said, based on how much data your controller can handle and how much memory overhead that you're willing to take on the JVM, because there are some static objects that we kind of keep around just so that we don't have to keep creating them every time a business transaction comes in. We kind of pre-create them and keep them in memory. So it has a memory footprint and the number of metrics and so on. But all the other stuff like snapshots and everything else, they have a limit as well. So they don't grow linearly with the number of business transactions. They kind of are still static. So there's no overhead in terms of snapshots and other stuff, but the memory overhead is what you should really think about.
And I also want to add quickly, if you found any of this extremely insightful and want to learn even more about stuff we're working on, the Java booth that's on the 4th floor in the booths area, Actually, we have demos there that have these applications running, and you can ask, I'll be there later with Vinay as well, but you can ask other product experts there, and they can showcase more capability to you as well that we couldn't get to in the presentation.
Does this GC code that you were talking about, does that work on Webster 855 IBM?
You mean the GC visibility in the IBM? Yes. So you can see this data on the IBM JVM as well. That's correct.
Okay.
So, at the IBM, a lot of this data we're able to extract through JMX, but if certain older JVMs, we have log-based capability enabled, so we'll actually parse your JVM GC logs and extract this data for you. So where their information is not available via JMX, we'll parse the logs at a polling frequency and show you the key metrics.
So if you have more questions, come up here and we'll take it offline.
Great. Thank you, guys. Have a great lunch.